Today we're going to take a look at complex numbers and dealing with quadratics. What happens when, for instance, I don't have any x-intercepts? How do I find solutions for quadratics? And so we're going to kind of start figuring out how to do that. And so what we deal with, and it's right here on page 248 in your book, is that we're going to start having these things called imaginary solutions. And you're like, imaginary? It's a way to solve quadratics when there are no real solutions, all right? So I'm going to kind of show you what it looks like, and we're going to start in example 1a by breaking down radicals with a negative sign in it, okay? And so basically what you've got to know is if I'm going to use an imaginary unit, we're going to call that I, that is equal to the square root of negative 1. So if we ever have a problem that's got the square root of negative 1 in it, we're going to substitute in I for that, all right? So we're actually going to take a couple different looks at complex numbers, and this is going to be part one. We're going to go break down this radical. Now, here's how I like to do it. When I go break down a radical, I want to make it positive, but I've got to kind of attribute this I thing to it. So if I have a negative sign in there, my first step, I'm going to pull it out front of my radical, and I'm going to call it I. So the square root of negative 27 for us is going to be rewritten as I times radical 27. Because I can go simplify the square root of 27, all right? So we pull that negative sign kind of out front, again, knowing that I is the equivalent of the square root of negative 1, and now we break down radical 27. When you're breaking down radicals, this is something we talked a little bit about at the beginning of the year. We're going to spend a lot more time doing it. You can break it down by factor tree. I'm not as big a fan of that. If you'll follow these steps, we're going to go to the calculator, all right? I'm going to go to y equals, and I'm going to do 27 divided by x. So the same way that we were looking at factors when we were factoring, we're going to do the same thing and look at the table. Now here's what we're doing. So my step here is I'm going to go to the table and do y equals 27 divided by x, okay? But I am looking for, and I'll write this down, the biggest perfect square factor in my number. So the biggest perfect square factor in this instance, that number is 27. So remember what perfect squares are. 4, 9, 16, 25, 36, etc. We're looking for the biggest perfect square factor. Now, when you look at the factors of 27, I've got 1 and 27. I've got 3 and 9. 9 is a perfect square, so keep that one in mind. I got to go make sure there are no other perfect square factors. I keep scrolling down. None of these with decimal factors count. And when I get to 9, I've already checked 3 and 9, right? Even though it's 9 and 3 here. So I've gone through all of them. So I'm going to come back and I'm going to break down. I'm going to rewrite I radical 27. And I'm going to write that as the square root of 9 times the square root of 3. Because I want to simplify this radical. For me, the easiest way to do that is to break down your biggest perfect square factor. If there's not a perfect square factor, don't use that factor. All right. The square root of 9 is 3, so it's going to come out in front of the radical. Remember, I had the I out in front of the radical, and then radical 3 cannot be reduced. A good indicator that you're good, that you're where you need to be is the number inside the radical is prime. That is not a 100% deal, okay? But there can't be any more perfect square factors, which there aren't in 3, and that's how you simplify the square root of negative 27. It turns into 3i radical 3. All right, I'm just going to go over here. I'm going to do part B, all right, which says look at or simplify the square root of negative 216. All right, so we've already seen, I got to get rid of, I can't take the square root of a negative. I mean, if you do that, you're not going to get a real solution. The calculator is going to give you an error message. Well, I can do it with imaginaries. So I'm going to pull the I out front. That takes care of my negative sign. So I'm rewriting square root of negative 216 is I radical 216. Then we're going to go on the calculator and do y equals 216 divided by x. We're going to look at our factors. 216 divided by x. Go to your table, second graph. Start back at 1, make sure we're good. All right, I'm looking for perfect square factors. You're like, well, coach, I don't know them. You just can maybe go write them down, maybe list them out. I would write them all the way from, 2 squared is 4. I might go from 4 to 100, which is 10 squared. Or just, you got to kind of have an idea. You just have to deal with it. All right. 2 and 108, neither of those are perfect squares. 3 and 72, no. Now 4 is a perfect square, so I got it. Maybe it's 4 and 54, but we got to keep going. Now look at this one, 6 and 36. You see how 36 is a bigger perfect square than 4? So right now I'm using 6 and 36. Let's keep going. 8 and 27, neither of those are perfect squares. Now 9 and 24, 9 is a perfect square, but remember 36 is bigger, so this is still my one I'm going to use. 6 and 36, let's keep going. See if we start repeating. 12 and 10, neither of those are perfect squares. See what I got? 18 and 12, oh, that's where we start repeating. We had 12 and 18, 18 and 12, so we're good. So again, I had several perfect square factors. 9 is a perfect square. 4 is a perfect square, but 6 had the biggest perfect square factor. So I'm going to break down again, I radical 216. I'm going to break that into, the square root of 36 times the square root of 6. We can take the square root of 36. That is 6, so it's 6. And then my I is out front, radical 6. Now, 6 isn't prime, but there are no perfect square factors in 6. So that's square root of negative 216 broken down. 6i, radical 6. There's a nice chart at the bottom of 248. Just kind of shows you what I is equal to, what I squared is equal to, etc. Just kind of keep that in mind. All right, just kind of keep that in mind. All right, let's look at simplifying. I'm going to kind of split this up into a couple parts that we can get here. When you simplify i's, it's just like a variable in terms of like terms. All right, so let's go to example 2, part A. It says simplify this, negative 5i times 3i. All right, so when we do this, really simple. I'm going to do my numbers times each other. Negative 5 times 3 is negative 15. Now I'm going to do I times I, which is I squared. Now the table on the previous page on 248 tells you I squared is equal to negative 1. So if you see an I squared, we're going to sub in negative 1 for that value. So what this problem really becomes in is negative 15 times negative 1. Which negative 15 times negative 1 is 15, and there's your answer. So negative 5i times 3i simplifies to positive 15. There's your steps right there. Okay? Same thing, example B. Same thing with radicals. Square root of negative 6 times square root of negative 15. We multiply, all right, the insides together, but you need to go ahead and get the i's out of there. Don't just do negative 6 times negative 15 yet, so we're going to rewrite this. I radical 6 times I radical 15. Now we can multiply the stuff outside together. So I times I is I squared. We can multiply the stuff inside together. 6 times 15 is 90. All right. This is going to clean up to negative 1. So it's going to be negative 1 times something. Again, I squared is negative 1. Let's go break down. Radical 90. 90 divided by x. Second graph, go to your table. Start at 1. 2 and 45, no. 3 and 30, no. 5 and 18, no. 6 and 15, no. Coach, why are you saying no? I don't have perfect square factors, okay? 4 was a perfect square, but it didn't give us a whole number. Keep going. There we go, 9 and 10. All right, so 9 is our biggest perfect square factor so far. We get to 10 and they start repeating, so that's what we want. So I'm going to break down radical 90 as square root of 9 times square root of 10. Sorry, I didn't give myself much room right there. All right, let me rewrite this. So we have negative 1 times. Remember, I am pulling this out. That radical 9 is 3. I'm leaving radical 10 alone. I can do this math in front. Negative 1 times 3 is negative 3, and that turns into negative 3 radical 10 is our simplified answer. All right, let's see how it goes. Not bad. All right, so how does this work for solving quadratics? So we're going to jump to example 3, and this will be the end of part 1 notes, and I'm done. I'm right in the middle of page 249. All right, example 3 says to solve this, x squared plus 64 equals 0. So you learned when you were factoring again that I can set this up when I have a quadratic and a constant that I can have it on one side. That's great. We can factor this and then we can see what we've got. So remember, if it's a perfect square and I have a, remember, that has to be a minus sign. So guess what? I can't do it. So we looked at this factoring, and guess what? It doesn't work because I have that plus sign there. When it's a plus sign, there's going to have to be 3 terms. So we can't do it this way. So we've got to have another way. Well, luckily we do. So x squared plus 64 equals 0. We can just go get x by itself. We can just go get x by itself. So here's what we're going to do. Okay, I'm going to subtract 64 from both sides. I get x squared equals negative 64. Now, to get rid of a squared, we take the square root. Now, this is a nice intro to when you take the square root of an answer. Okay, when you had a quadratic and took the square root, you have two answers, a positive and negative answer. Okay, so what I've got here when I take the square root of negative 64 is plus or minus square root of negative 64. Now, let's go through what we've learned today. All right, x equals plus or minus. I'm pulling the negative out front. We call that I. So I have I times radical 64. Now, 64 is a perfect square. So I hope you know the square root of 64 is 8. But if you don't, I want to show you what that looks like in the calculator. I'm going to do 64 divided by x. Go to my table. Start at 1. 1 and 64. Again, 64 is a perfect square. All right? So this is going to break our rules a little bit, but I want to show you what it looks like, and it kind of points itself out. 2 and 32, no. 4 and 16 are both perfect squares. You know, technically 1 and 64 are both perfect squares, okay? Keep that in mind. And I get to 8 and 8. You see how they're the same thing? That's telling you, hey, it was a perfect square. So if that starts happening, look for that pattern of, well, if I have two of the same number, it's a perfect square. So the square root of 64 is 8, and I'm going to rewrite it and get my final answer like this, plus or minus 8i. And that, we put the I behind just like we put a variable behind. That's my answer. There are my two solutions to that quadratic. All right? We're going to spend a lot more time with this. We're going to do some more stuff. I'm going to split this up into a couple of sections or a couple of parts. That's the first part, understanding imaginary numbers and how they can help us start solving quadratics. Thank you.